Hey everyone, today we are going to solve LeetCode problem number 606, construct string from binary tree. So in this problem we are given a root of binary tree and we have to construct a string consisting of parenthesis and integer from a binary tree with a pre-ordered traversal way and just return it. And we also have to omit all the empty parenthesis pair which do not reflect any one-to-one mapping. Okay, so we are given a tree and we have to convert this tree to a string so that string and tree will have a one-to-one mapping. It means if someone is given a string, he should be able to construct this tree back from that string. So we are given a root of that binary tree and we just have to return string. Okay, so in this case, let's say for this given example, we have to construct string in a pre-order fashion. So will be in the starting, and then the left subtree, right subtree. For the left subtree we are going to use braces, and for the right subtree we are also going to use braces. On the right subtree we only have one node, so we are going to return 3. On the left subtree, now this will behave as a root, and then left child, then right child is empty. So root, left child with braces, right child we don't have. Or if we place bracket here, so these are of no use, so we won't use these brackets. So this would be our answer, our string, and from this string we can construct this tree back. Like, one is the root. Now this is the left sub part, this is the right sub part. Right sub part we only have 3. On the left sub part, 2 is the root, and then there is one left subtree which is 4. So we are able to construct this tree back from the string. Okay, so how do we solve that? We can solve that using recursion in pre-order fashion. Okay, so while solving this problem we might encounter 4 cases. So every node, it will fall from one of these 4 cases. The first one, if we consider the first one, if it is a leaf node, or maybe it does not have any left or right child, it means for that, what would be the string? We can directly return the string, which is 1. This would be our answer. For the left subtree, root, bracket, left part, then bracket, right part. For case 3, it would be root, bracket, left part, bracket, right part. Root, bracket, left part, bracket, right part. So this one is clear to us. This can be our corner case, or maybe recursion terminating case. For the case where we only have left child, do we really need this bracket? If we don't have a bracket for right subtree, it means it's understood that right subtree is not present. Or if we don't have left subtree, so can we remove this bracket? No, we cannot remove this bracket, because if this is removed, 2 will be considered as the left subtree, because this is a pre-order fashion. First root, then left subtree, then right subtree. Okay, so for for the case where we only have the left subtree, it will be root, then left subtree. We will omit the right subtree brackets. Where we only have the right subtree, it means we have to use the left subtree and the right subtree. So we are going to use left subtree whether there is any left or right child. Okay, if there are both the trees, then we are good with both the trees. Okay, so from these two conditions, we got to know that if root dot left not equal to null, or root dot right not equal to null, if we have any one of the left or right subtree, we are going to use left bracket and string of left part. For the right subtree, if right subtree is not null, root dot right not equal to null, left bracket, right bracket, string, right. Okay, so these can be our condition for recursion. And when we will do the termination, whenever left subtree and right subtree are null, it means we can just return the string, or the edge case can be like if root is null, then we can directly return null. Okay, let's try over this example as well. So this is 1, 1 is the root, so 1. Now we have to use, do we have the left subtree? Yeah, right. So do we have the left subtree? Yeah, right. So we will use left subtree with this bracket. Now the further call will go to 2 as a root. Now it does not have right subtree, but it has left subtree. It means we, okay, so 2 will be behaving like a root, and as it does not have left subtree but have right subtree, it means we have to consider the left subtree as well. So 1, 2 is the root, left subtree, right subtree is 4, and then further for 3, 3 is our right subtree, and this will be the string. So if we try to construct tree back from the string, 1 is the root, this is for the left, this is for the right. Right is simple. For the left, 2 is the root. Now there is empty bracket. It means the left subtree is empty. For the 4, 4 will be the right one. So we are able to construct back this tree from the string. Okay, let's try to code this out. Okay, let's try to code this out. Here we have 4 cases when the root is not having left or right child, or maybe having only left or maybe only right child, or having both the case, both the subtrees. So for firstly check for the null condition. If root equal to null, in that case we are going to return empty string. If it is a leaf node or maybe does not have left and right child, if root dot left equal to null and root dot right equal to null, in this case we are clear that we have to return root dot value. I'm just converting it in a string. Okay, now we have to check for left left subtree. For the left subtree, when we have to consider the left subtree, when either of the subtree exist. If left root dot left is not equal to null, or if root dot left is not equal to null, or root dot right dot not equal to null, it means whether there is left or right, any one of the tree exists. In this case we are going to return, let's capture a string separately. String s equal to empty in the starting. Now string plus equal to, now we have to capture the left, so we will use left in this case, left and right bracket plus tree to str root dot left. Okay, even if right subtree is not null, in this case we are going to capture left. If root dot right not equal to null, it means we have to capture the right one. S plus equal to root dot right with brackets. Now we are going to return s. Okay, so s was empty in the starting. We also have to add root in it. S, maybe initialize s with the root, equal to plus root dot value. If root is not null, and if it is a node, not a leaf node, let's say for this example, 1 will be captured, and then left is not null, 2 will be captured, and then make a recursion call on the left sub part. If right is not null, make a recursion call to right sub part. Try to submit it. Submitted successfully. Hope you understood the problem. Thank you guys.